What if I told you that right now at this very moment something is passing through our solar system and is not behaving like anything we've ever seen before? Astronomers first called it a comet, then they noticed something unsettling. It wasn't just moving, it was interacting. And now Mars is changing. What if the universe is quietly telling us that one of our oldest assumptions is wrong? For centuries, we believed comets were among the simplest objects in the cosmos, dirty snowballs drifting along obedient, predictable paths, shaped by gravity and sunlight, doing exactly what our equations say they should do. We've cataloged them, modeled them, and in many ways tamed them. When astronomers first labeled 3I Atlas as a comet, it fit neatly into that comfortable story. But science advances not when things behave as expected, but when they don't. And 3I Atlas does not. When you look closely at its motion, something unsettling appears. Comets respond to gravity and solar heating in well-understood ways. As they approach the sun, ice sublimits, jets of gas push them slightly off course, and those deviations are chaotic, messy, and irregular. But 3I Atlas shows adjustments that are subtle, smooth, and strangely efficient. Its trajectory doesn't wobble the way a natural outgassing body should. Instead, it appears to correct itself, not dramatically, but just enough to maintain a particular path. In physics, when nature takes the shortest, most efficient route again and again, we start to wonder whether something is optimizing the process. Then there is the matter of its emissions. Typical comets glow as sunlight excites simple molecules, water vapor, carbon dioxide, carbon monoxide. Their brightness rises and falls in predictable cycles tied to distance from the sun. But 3I Atlas doesn't merely brighten, it modulates. Its emissions fluctuate in patterns that repeat with uncanny consistency, as if responding to external conditions in real time. This is not random behavior. Random systems produce noise. Ordered systems produce structure. And structure in physics always demands explanation. Some have argued this could still be natural. Perhaps an exotic composition, or an unfamiliar interaction between solar radiation and interstellar material. And that is a fair argument. Nature has surprised us before, but here's the problem. To explain 3I Atlas as natural, we must stack improbability upon improbability. We must assume a composition never observed, dynamics never recorded, and interactions never predicted, all appearing together in one object. Science prefers simplicity. When explanations become excessively complex, we know we're missing a deeper principle. Now consider where this object chose to pass. Not randomly through empty space, but near Mars. Mars is not just another planet. It is a fragile world, its atmosphere thin, exposed, and exquisitely sensitive to external forces. It is the perfect detector. If something unusual were to interact with a planetary atmosphere, Mars would show it first. And in 2026 observational data, that is exactly what we see. The Martian atmosphere should change slowly over tens of thousands or millions of years. Solar wind strips it away molecule by molecule. Seasonal variations shift dust and carbon dioxide, but the underlying structure remains stable. Yet now, localized regions show increased ionization, elevated levels of charged particles, and chemical reactions occurring at energies slightly higher than expected. These are not global storms or solar flares. They are focused, subtle, and persistent. In other words, they look like the signature of an external influence passing nearby. This is where physics becomes uncomfortable. Ionization requires energy. Energy must come from somewhere. We can trace solar activity, cosmic rays, and known space weather, and none of them align perfectly with what Mars is experiencing. The timing, however, aligns remarkably well with the passage of 3I Atlas. When an object moves through space and leaves a measurable imprint on a planet's atmosphere, it is no longer just a passive traveler. It is an active participant. Think about what that means. For the first time, we may be observing an interstellar object not merely reflecting sunlight, but interacting with a planetary environment in real time. This interaction is not violent. It is gentle, almost surgical. It doesn't tear the atmosphere away, it nudges it, it excites it. It alters it just enough to be noticed, but not enough to cause chaos. In nature, such restraint is rare. Energy usually dissipates wildly. Precision, on the other hand, is a hallmark of control. Skeptics will say, this does not imply intelligence, and they are right. Physics does not jump to conclusions, but it does follow evidence. And the evidence tells us that whatever 3I Atlas is, it cannot be treated as a simple comet. The old category fails. Our equations strain, our models whisper that something new has entered the picture. What makes this moment profound is not fear, but humility. For centuries, humanity believed the heavens were static, distant, and indifferent. Then we learned they are dynamic, then we learned they are violent. Now we may be learning they are subtle, that the universe doesn't always announce itself with explosions and flashes of light. Sometimes it reveals itself through quiet deviations, through small changes in atmospheric chemistry on a red planet millions of kilometers away. Mars, in this sense, becomes more than a world we hope to visit. It becomes a mirror, reflecting back to us the limits of our understanding. If a passing object can measurably influence its atmosphere without direct contact, then our picture of interstellar space as empty and inert is incomplete. Space may be threaded with interactions we have barely begun to measure. This is how scientific revolutions begin. Not with certainty, but with discomfort, not with answers, but with questions that refuse to go away. 3I Atlas challenges us to rethink what we mean by a comet, what we mean by an interstellar visitor, and how deeply connected planets are to their cosmic environment. And once you see that, you can't unsee it. Because the universe has just shown us that even small objects passing silently through the dark can leave fingerprints on entire worlds. For decades, we assumed we understood how visitors from other star systems behave. Interstellar objects, by their very nature, are cosmic vagabonds. They enter our solar system at enormous speeds, guided by the gravitational momentum they acquired over millions of years of travel through the galaxy. They do not slow down. They do not linger. They pass through like arrows shot from the dark, offering us only a brief glimpse before disappearing forever. That assumption was shaken once before, when an object showed no obvious tail yet accelerated in unexpected ways. But even then, it behaved like a traveler in a hurry. What we are witnessing now is something fundamentally different. 3I Atlas does not behave like a visitor passing through. Its velocity profile suggests a strange patience, as though it is not merely falling through the sun's gravity well, but interacting with it. In classical mechanics, this is unusual. Gravity accelerates objects, it does not negotiate with them. Yet the data show that 3I Atlas maintains a trajectory that maximizes observational proximity to key regions of the inner solar system. It neither plunges inward recklessly nor escapes outward immediately. It lingers just long enough to matter. In astrophysics, lingering is a red flag. It demands energy exchange, and energy exchange demands a mechanism. Natural explanations stretch thin here. Interstellar objects should not conveniently decelerate without expending enormous amounts of energy. There is no dense medium in space to slow them down, no friction, no atmosphere. To reduce speed, an object must actively shed momentum. If that shedding appears controlled rather than chaotic, then we must at least entertain the possibility that we are not dealing with a passive rock or ice body. Even if the mechanism is natural, it is something new, something not yet cataloged in our textbooks. And science advances precisely at these fault lines where old rules crack under new observations. Then there is the question of intent, not in the emotional sense, but in the physical sense. Physics does not ask why in the philosophical way. It asks why in terms of forces and outcomes. When an object behaves in a way that maximizes interaction and information exchange, physicists take notice. A stone does not adjust its fall to pass near sensors, but an engineered probe would. This does not mean that 3I Atlas is artificial. It means that the universe is presenting us with behavior that sits uncomfortably close to the boundary between natural complexity and purposeful motion. Now consider its energy signature, because energy never lies. Everything in the universe announces itself through energy, heat, radiation, vibration fields. We can hide secrets from our eyes, but not from our instruments. When astronomers analyzed the electromagnetic output of 3I Atlas, they expected chaos, the noisy broadband emissions typical of natural bodies interacting with solar radiation. Instead, they found something quieter, cleaner, and oddly structured. Not a signal in the cinematic sense, not a message or a code, but a pattern. a rhythm. Random systems smear energy across frequencies. Organized systems concentrate it. The emissions from 3I Atlas sit in a narrow band, fluctuating in a way that suggests regulation rather than accident. It is as if the object is shedding energy just enough to maintain stability, like a spacecraft adjusting orientation using minimal fuel. Again, this does not prove technology, but it does prove one thing beyond doubt. The physics involved is not simple. Some propose exotic explanations, unknown plasma effects, unfamiliar quantum interactions, or rare states of interstellar matter. These are valid avenues of inquiry. But notice what is happening. To keep 3I Atlas comfortably inside the box of natural object, we are forced to invoke layers of speculation. The explanation becomes increasingly baroque. In science, when the explanation grows more elaborate than the phenomenon itself, it signals that we may be asking the wrong question. The deeper question is not whether this object is artificial, but whether our definition of natural is too narrow. The universe has had 13.8 billion years to experiment. It has built stars, galaxies, black holes, and structures so complex that they bend space and time. Is it really so shocking that it might also produce objects whose behavior mimics design? Or conversely, that intelligence elsewhere in the cosmos might have learned to move in ways that resemble nature so closely we struggle to tell the difference? This is where emotion enters science, not fear, but awe. We are confronting the possibility that the line we draw between natural and artificial may be a human convenience, not a cosmic truth. Energy signatures that are subtle, controlled, and efficient suggest mastery over physical laws, whether achieved by evolution, by chance, or by intelligence. And if such mastery exists anywhere, it forces us to reevaluate our place in the cosmic hierarchy. What makes this moment powerful is its quietness. There are no explosions, no dramatic signals beamed at Earth. Instead, there is a whisper in the data, a gentle insistence that something does not fit. And that whisper is often how the universe speaks before it shouts. We have seen this before in history. Tiny irregularities in planetary motion led to the discovery of Neptune. Slight discrepancies in Mercury's orbit led to Einstein's theory of relativity. Small anomalies change everything. 3I Atlas may turn out to be entirely natural, and if so, it will expand our understanding of interstellar physics in ways we cannot yet imagine. But even in that outcome, the lesson remains profound. The universe is not obliged to behave in ways that make us comfortable, but is far stranger, more elegant, and more subtle than our current theories allow. And when an object from another star system enters our cosmic neighborhood and refuses to behave as expected, it is not a threat. It is an invitation to think bigger, to question deeper, and to accept that the universe may be far more alive with complexity than we ever dared to believe. When we imagine an advanced force interacting with a planet, our instincts betray us. We picture invasion, extraction, domination. We project our own history onto the cosmos. But physics offers a colder, more intriguing possibility. If an advanced process, natural or otherwise, wanted to understand how a planetary atmosphere behaves, it would not choose Earth. Earth is loud. Earth is messy. Life interferes with every variable. Mars, on the other hand, is quiet. Thin atmosphere. Minimal chemistry. No oceans to complicate measurements. It is, from a scientific standpoint, the perfect laboratory. If you were conducting a controlled experiment, you would never start with the most complex system. You would begin with the simplest. Mars fits that requirement almost too perfectly. Its atmosphere is fragile enough that small inputs create measurable effects, yet stable enough that those effects can be isolated. When we observe changes on Mars, coinciding with the presence of 3I Atlas, the possibility emerges that Mars is not the target of aggression, but the subject of observation. Not a battlefield, but a test bed. This reframes everything. Instead of asking why Mars is being altered, we ask how delicately the alteration is occurring. The changes are subtle. No catastrophic loss of atmosphere, no dramatic temperature spikes. Just gentle excitation, localized ionization, and chemical shifts that hint at energy being introduced with remarkable restraint. In nature, restraint is rare. In experimentation, It is essential. A good experiment perturbs a system just enough to learn from it, but not enough to destroy it. That thought is unsettling, not because it implies hostility, but because it implies sophistication. Whoever or whatever designed such an interaction would understand planetary physics deeply. They would know how much energy is too much, how much is too little, and how to remain nearly invisible while gathering meaningful data. Even if this process is entirely natural, it behaves like intelligence because it mirrors the logic of experimentation. And that alone forces us to confront how narrow our assumptions have been. Now, consider us watching all of this unfold. Humanity likes to believe it stands at the cutting edge of knowledge. We split atoms, we map genomes, we send machines beyond our solar system. But in cosmic terms, we are infants. Our oldest radio transmissions have traveled barely 100 light years. That is a tiny bubble in a galaxy 100,000 light years across. We have been technologically visible for the blink of an eye. Imagine a civilization not millions of years ahead, but merely 1,000. 1,000 years is nothing on the cosmic time scale. Yet the difference between us and humanity 1,000 years ago is staggering. To them, our satellites, smartphones, and artificial intelligence would appear indistinguishable from magic. Now reverse the perspective. If something 1,000 years ahead of us were operating nearby, would we even recognize it as technology? Or would we dismiss it as an odd natural phenomenon because it does not fit our expectations? This is the uncomfortable truth. Our detection methods are primitive. We look for loud signals because that is what we know how to produce. We search for radio waves because radio waves are our invention. But a more advanced entity would have long since moved beyond such crude broadcasts. Efficiency is the hallmark of progress. Waste is a sign of youth. Broadcasting your presence across the galaxy is wasteful. Subtle interaction, on the other hand, is efficient. In that context, 3i Atlas feels less like a visitor announcing itself and more like a presence passing quietly through, leaving behind only the faintest trace of its influence. This is not how toddlers behave. This is how experts behave. And that realization should not frighten us. It should humble us. Science fiction often imagines first contact as a dramatic event, but reality is rarely dramatic. It is incremental. It creeps up on us through data points, through anomalies, through results that refuse to go away no matter how often we rerun the calculation. If intelligence exists elsewhere and the sheer number of stars makes that statistically likely, it would not need to conquer us to surpass us. It would only need to understand the universe a little better than we do. That is the emotional core of this moment. Not fear of being watched, but the quiet realization that we may not be the smartest observers in the room, that the universe may host processes and intelligences that operate with a patience and subtlety we are only beginning to grasp. When we see Mars responding gently to a passing object, and when we see energy signatures that suggest control rather than chaos, we are forced to confront our own developmental stage. We are not late to the universe, but we are early in our education. The cosmos has been running experiments for billions of years. Stars live and die. Galaxies collide. Civilizations may rise and fall without ever crossing paths. In that vast timescale, humanity has just opened its eyes. And perhaps, just perhaps, something else has noticed that we are starting to look back. For most of modern history, our search for life beyond Earth has been guided by a simple assumption: if someone is out there, they will try to talk to us. We built giant radio telescopes and aimed them at the stars, listening for intentional signals, patterns, pulses, messages that would announce intelligence loud and clear. This approach made sense because it reflected who we are. We shout before we whisper. We broadcast before we observe. But the universe has a way of humbling us, and events like 3i Atlas suggest that intelligence, if it exists elsewhere, may not reveal itself the way we expect. The more we study the cosmos, the more we realize that signals can be inefficient. They degrade over distance, drown in cosmic noise, and reveal the sender's location to anyone listening. A truly advanced presence would not need to announce itself with radio waves. It could learn far more by watching how systems respond to gentle influence. Behavior, not communication, becomes the giveaway. How an object moves, how it interacts, how it alters its surroundings just enough to leave a trace. In that sense, 3I, Atlas, forces us to rethink the very definition of evidence. When we see an object that does not merely pass through space, but engages with it, adjusting its motion, interacting with planetary environments, leaving behind measurable changes, we are no longer looking at a passive phenomenon, we are looking at behavior. And behavior is the universal language of intelligence, whether biological or artificial. Even here on Earth, we infer intelligence not from words alone, but from actions. A footprint in the sand tells us more than silence ever could. This realization marks a turning point. The search for life is no longer just about listening harder, it is about observing more carefully. We must learn to detect intention through motion, learning through interaction, curiosity through restraint. A system that nudges rather than disrupts, that observes without interference, reveals a mindset fundamentally different from our own early technological adolescence. It suggests maturity, patience, long-term thinking. And this brings us to the most profound implication of all. The universe is no longer a silent stage upon which humanity performs alone. It is an active environment filled with processes that may be natural, artificial, or something in between, processes that respond, adapt, and influence. Mars changing under the quiet presence of a passing object is not just a scientific curiosity. It is a message written not in language, but in physics. Whether 3I Atlas is the product of exotic natural forces or advanced engineering, it delivers the same emotional truth. We are no longer justified in assuming that the universe is indifferent. Indifference leaves no patterns. Indifference leaves no fingerprints. What we are seeing now are subtle hints that complexity and perhaps awareness may be woven far more deeply into the fabric of reality than we once believed. This does not mean humanity is insignificant. On the contrary, it means we are finally reaching the point where we can notice these whispers. For billions of years, the universe did not care whether we understood it or not. Now, for the first time, we have instruments sensitive enough to detect deviations that challenge our worldview. That is not a coincidence. That is progress. Emotion enters science at moments like this, not as fear, but as wonder. The realization that we may be students in a much older classroom reshapes our sense of purpose. If the universe contains observers other than ourselves, then knowledge is not a lonely pursuit. It is a shared endeavor across time and space, carried out in ways that transcend language and culture. The silence we once feared may never have been silence at all. It may have been subtlety. And now, as we learn to read the faint signatures left behind by objects like 3I Atlas, we are tuning our senses to a deeper frequency of reality, one where the universe does not shout its secrets, but invites us to earn them through curiosity, patience, and humility. As we stand here looking out into the vastness of space, one truth becomes impossible to ignore. The universe is no longer a distant, silent backdrop to human ambition. It is active, subtle, and endlessly surprising. Objects like 3I Atlas remind us that discovery does not always arrive with fireworks. Sometimes it comes as a quiet discrepancy in the data, a gentle change in a planet's atmosphere, a question that refuses to disappear. Whether this phenomenon turns out to be an exotic natural process or evidence of intelligence operating far beyond our current understanding, it has already done something remarkable that has expanded our imagination. It has forced us to confront how little we truly know and how much more there is to learn. And that, at its core, is the beauty of science. Every answer opens the door to deeper questions, and every mystery brings us closer to the universe we are trying to understand. Thank you for taking this journey, for staying curious, for questioning assumptions, and for exploring the unknown with an open mind. Your curiosity is what drives discovery forward. Until next time, keep looking up, because the universe always has more to tell us.